Hello and welcome to another NathanDumont.com video blog. So today's episode is entitled How Not to Build a RepRap. I've actually got a RepRap here, so I must have done something right. But there's a lot of guides out there telling you how to build a RepRap, so I figured I may as well say just what went wrong. So the first question is, what is a RepRap? A RepRap is a replicating rapid prototyper. So like the MakerBot and the new PrinterBot, it prints using plastic filament, which it melts and extrudes somewhat like a glue gun, and then moves this carriage around in the X direction and the bed in the Y direction and up and down to create a 3D object on the bed. It's called replicating because it can print its own parts. So all these white parts you can see in my RepRap have been printed on another RepRap, which is how it got created. How do you start a RepRap then? There's a couple of different ways. Something called a rep strap, and you can build them out of wood and all this kind of thing. I cheated and just bought these parts. I bought them off RepRap Limited, which is run by Adrian Bowyer, who invented the RepRap in the first place, and he printed these on one of his machines. Then you need the threaded rod and nuts and bolts and things. I bought a kit for most of that because it contained some hard to find parts and wasn't that much more expensive than sourcing all this kind of thing myself. So the tooth belts were specified as needing to be 5mm wide. Having seen how much space there is there and things, a normal 6mm one that you can get relatively easily would have been fine, so long as the pitch is right. So the framework is all made out of threaded rod. The carriage bars are just smooth steel rod. So the other part I had to get, other than the framework and the plastic printed parts, is the stepper motors. Now the stepper motors here, I've got 5, so there's 2 for the Z axis, 1 for the X and 1 for the Y, and a 5th one here on the extruder. Now the extruder one was specified as having to have a minimum torque, so this is a slightly more powerful model than the others, although it costs the same. Now if I was going to do it again, I'd go for all this Zap Automation 1684A model. The only reason for that really is it comes with a flat on the shaft, which saves, I had to file flats on the shafts for X and Y because of the torque when you change direction of the table very rapidly, and the wires on it were much longer, so all these wires here that run from the motors around I've had to extend, which is a lot of extra soldering. So the final major component of the RepRap is the electronics and the controller board, and I've got the Sanguino Lolu, which is a fairly current one. It uses the Sanguino, which is an Arduino compatible 40-pin Atmega, something between the Arduino Uno and the Mega really, and 4 of these Pololu A4983 stepper driver boards, which actually control the 5 stepper motors. So the Z steppers are joined together here and driven by just the one controller. So this has got, my version hasn't got the RS232 USB adapter on board. I've used the FTDI 232 TTL breakout cable, which just plugs on the header there. This is the heater, thick wires going off to the heater there, and the switch to turn it on and off. Onboard regulator there, and the connector here is the temperature sense from the hot end. Limit switch is over this side, and power comes in at the bottom here. Currently I'm using an old PC power supply to run it all off. I've got one of these 30 amp 12 volt switches for £20 off eBay, which is recommended on the Adrian's Prusa notes on the RepRap wiki. I haven't wired it up yet. as you can see, the contacts are somewhat exposed, so I'm planning to put that in a box with a proper IEC mains inlet and things before I power it up. So what's gone wrong? Well, like I said, I would probably change the motors. Not a huge problem, and they work just fine. This chip has caused me quite a bit of trouble. The bill of materials on the RepRap wiki states that it is an 80 mega 644. I ordered one of those and tried to program it and discovered that it is not in fact an 80 mega 644 but a 644p, which I may have known if I knew more about Atmel AVRs, but I haven't used them before. So that's one to watch out for. There is a note in the wiki, but it's not actually corrected in the bill of materials. So you need to make sure it's the 644p, otherwise it just won't program. With the Arduino, or the Sanguinalolu firmware, bootloader firmware. So once that was programmed up, I bunged in my serial cable and had a go at downloading the sketch. So the firmware for the RepRap is written as a sketch. So I'm using Sprinter firmware, but that didn't work either. And I've since discovered there's an added jumper here which is connects the reset line, and there's a 0.1 mic capacitor which is listed in the parts for the USB interface, but is also required if you don't use the USB interface and just drive off this header, but it's not clear from the bill of materials. So I looked that up on the circuit diagram and we got that in, and it's away. The other main problem I've had with it is configuring the extruder steps per millimeter parameter in the firmware. Now this parameter is set in the Arduino sketch before you download it to the Sanguino. There are two definitions depending on which software you're using. One is the number of steps of this stepper motor to extrude 1 millimeter of plastic from the nozzle. The other definition is how many steps of the stepper motor to draw in 1 millimeter of plastic filament into the extruder. Now, because this is 3 millimeter plastic and a 0.5 millimeter nozzle, there's a factor of 36 difference there. So for every millimetre of plastic drawn in, you should get around 36 millimetres of extruded plastic out of the nozzle. So clearly if you get it wrong, and you've told it the wrong parameters, and this is then drawing in 36 times as much plastic as it should here, you get a lot of mess here, and in fact the chamber fills up and it can't extrude anymore. And vice versa, you get the same problem. If it's drawing in enough plastic here to generate 1 millimetre here, but it is expecting 36 millimetre extruded, you can't see it printing anything. The other big danger, if you get the number of steps per millimetre wrong, it uses reversing this draw wheel which draws the plastic in. It reverses it to suck on the nozzle and stop it from oozing while it's travelling. Now if you've got the number of millimetres, steps per millimetre wrong, and it sucks too far and sucks a whole load of this out, say 36 millimetres of this, instead of sucking back just 1 millimetre of extrusion, you can end up with the molten plastic wrapped around your knurled bolt here, which takes ages to clean out. You've got to take all this spring assembly off and clean it out. So make sure you get it right. So the old-fashioned way is to measure millimetres of extrusion here, and that's used by the RepRap host software and old versions of SkeneForge. The current way for SkeneForge and SFACT is the number of millimetres of plastic here, and then you tell them how the diameter of your plastic. So I measured it with my micrometer, 2.85 millimetres. This particular reel is extruded at, and enter that in, and it calculates how much plastic you need. Backlash can be a problem. Usually when something's gone wrong, because the timing belts are normally supposed to be kept fairly tense, so that you don't get any significant backlash. To give you an idea of what it can do, so this is started off as a round ball bearing ball race and ended up really quite oval. Now this is because the motor here was running pretty much at max current and it was getting hot enough. It's actually melting the PLA, which this X support bracket is made of, and bending it instead of moving the carriage. And so this assembly wasn't moving backwards and forwards, but this motor was moving. The same can happen for the Y-axis. I put a cable tie around the Y-axis to kind of stabilise it a bit. I'm not sure what to do about this. For now I've just turned the current down and it still seems to be working okay, but after a long time running it can still get quite hot, and the PLA is quite soft. Some people have suggested that ABS parts are better from that respect. Perhaps I just need to turn the current down a bit more. The other reason you can get this kind of backlash is the pulley on the stepper spindle has come loose. Now I've got flats on the shaft, so the pulley when it comes loose can only move a certain amount before it hits the side of the flat, because the bolt won't turn around the whole shaft. But that still gives you ovals where you'd expect to get a nice circle. So this is one of the original pulleys that I got in my kit, and hopefully you can see it's actually oval, the centre hole there now, because it's stretched. And the other problem, you can see the nut there isn't very tight in the rebate for it. So when you try and do the bolt up really tight, the nut just spins around and you don't ever get it done up really tight. Added to that, the dimensional tolerance of these printed pulleys, and I'm thinking I'm probably going to replace them with aluminium machined ones, which you can get from Farnell or Zap Automation, that I got the steppers from, or other industrial automation suppliers, because it's a standard T5 timing belt. Having got it all working, what's the coolest thing I've printed? Homemade Lego. Awesome.